Welcome to qnawire.
Okay, in this problem, we're talking about using a dehumidifier to reduce the vapor pressure to reduce the relative humidity from 95% to 40%, which is a lot more reasonable in a house. So if we assume a temperature of 20 degrees Celsius and a room in a house, well, or rather an entire house of 115 square meters and a height of 2.8 meters, we need to find the total amount of water mass that needs to be removed from this space to get the humidity down. So we're given a temperature. We basically have a volume because we have a floor area times a height. So the volume is 115 square meters times 2.8 meters, gives us that value. The rest of this is just using the ideal gas law and a table to get vapor pressure. So to start us out, we know that at 20 degrees Celsius from table 18-2, the saturated vapor pressure is 2.33 times 10 to the 3 Pascal, just consulting the table, which is used a number of times in this chapter in these problems. We can use the ideal gas law to essentially find the number of moles of water in the air in both these cases of 95% and 40% humidity. Okay, and we just take the difference in the mole amounts and multiply by the molar mass, and that will give us the water mass. So the difference in moles is just going to be, assuming the volume and the temperature are the same, which they are, it's just going to be the difference in pressures. And this is ideal gas law. Let's just write it up there for reference. It's PV equals little n RT. R is the gas constant. And so this really all follows. The only thing that's really changing, V over RT, got a vapor pressure times the difference in humidity, which is 0.95 minus 0.4. We just plug in our vapor pressure, our volume, and our temperature, and the gas constant, and we can just calculate this change in moles, which turns out to be 169.4 moles. That's the amount of water in moles that needs to be removed in order to get this change in humidity at constant volume and temperature conditions. And the last step here, to get our actual mass of water, is to just take the change in moles and multiply it by the molar mass for water. So we take our 169.4 moles. We can just look up the molar mass of water, so the number of kilograms per mole, which is 18 times 10 to the negative 3 kilograms per mole. Simple multiplication gives us kilograms, gives us exactly 3 kilograms of water that needs to be removed. So it's actually not that much. So just to recap, what we did is we consulted table 18-2 to get a vapor pressure for the water. And then we used the ideal gas law to determine the change in moles of the gas if the pressure is changing under constant volume and temperature conditions. And the actual change in pressure is just our vapor pressure times the change in relative humidity. Once we have the number of moles, we can multiply by molar mass to get the mass of the water. And that's it.